Hello and welcome back to the channel. In the last video, we looked at 6 of the methods of the math class. And in this video, we're going to be looking at the remaining 4 methods. Now you don't have to watch the previous video to watch this one, but I definitely do recommend it because all 10 methods are really important. Now the last 4 methods are simple, but they could take a little more time to explain and a little more time to master as well. So the first method we're going to look at is the math.round method. So currently I'm in my code editor, and what we're going to do is we're going to look at a simple program that uses the round method. So if you look at the syntax for the round method, it's the same as all the other math class methods. We just say math dot the name of the method, in this case round, and we add these brackets and we enter the parameters in this bracket. Now as the name suggests, what the math.round method does is that it takes in a value, it rounds it to its nearest integer and then returns it. So if I were to say enter 3.9, it should ideally return 4, which is again 3.9 rounded to an integer is 4. Now if I enter 3.3, well then it will obviously enter 3 because the closest integer value is 3. Now you could just try something out. Maybe if it's something like 4.5, it would round it to 5. If it's 4.2, it would round it to 4. And you get the idea. It's just something that can round a value to the closest integer. So I added a scanner class, and what I'm doing is I made a scanner object to take in input just so that I can enter different kinds of values and test out how my round method works. Right, so as you can see, I wrote this simple program where I take in a decimal value as input and I store it in a variable called a. And what I'm doing is I'm just printing math.round of a. And this should ideally, if I enter a double value, it should return an integer. Basically, it should round that double value a to the closest integer. Now let's just run this program. So as you can see, it's asking me to enter the value. And let's say I enter something like 4.3. It should round this to 4 and it should print that since I have a println statement. And when I click on enter, it gives me 4. So it works really well. Now I could enter a different value, something like 4.6, which should give me 5, and it does give me 5. Now what if I enter an integer? I don't enter 4.6. I just enter 4. So let's just run this again, and now we'll enter 4 over here. What should happen? Now before I run this, let me think of what could happen. When I enter 4, right, I'm entering a value of 4 into a double value of a. It gets implicitly converted into a double. So 4 over here is implicitly converted to 4.0 by the compiler. So when I run this, 4.0, which is rounded, is just 4, right? So when I run this, I get 4. And this makes perfect sense. Now what if I enter an actual integer? So instead of having these println statements, I enter an actual integer like 3. In this case, what should happen? So when I run this, you'll see I'll still get 3. It rounds 3 to 3 because 3 over here in the same way is implicitly converted to 3.0, which is then rounded to 3. So this makes perfect sense. Now the reason I explain this, which might seem a little confusing, is to just show you that you can enter both an integer value or a decimal value as the input or as the parameter for your round method, right? And the return data type is obviously an int. It always returns an int, never a decimal. And now we're going to look at the math.ceil method. So a syntax for the math.ceil method is the same. It's just math.ceil and you will add these brackets. So the parameter for your math.ceil method is a double. Now what your math.ceil method does is very simple. It just rounds that decimal value or a double value to the next or the next higher closer integer. For example, if I enter something like 3.2, normally a math.round method would round it to the closest integer, which is 3. A math.ceil method rounds it to the closest to the next closest integer. Basically, it's going to round 3.2 to 4.0. Now, you do notice one thing. I said 4.0, not 4. Now this is an exception with the math.ceil method. You would expect that since you're rounding a decimal value to the next closest integer value, it should return an integer, right? But in reality what happens is your math.ceil method actually returns a double. So this is counterintuitive, but it is sometimes really important to remember, considering the fact that you cannot implicitly turn a double into an integer. So in this case, if it's returning a double value and I'm storing it in an int variable or an int data type variable, it's going to cause an error, because we know that a double value cannot be implicitly turned into an integer. So I wrote a simple program over here where I'm entering a value which is going to be a double value. I'm storing it in this variable called a, which is of the double data type, and once I do that, I'm just going to print the math.ceil of a. So let me just add that sentence over here. Now as you can see, I added a println statement that basically prints math.ceil of a. A is the parameter for the ceil method, and in this case you could kind of assume what your output could be. So let me just first run this program. Now let's enter a value like 4.6. Now I told you a math.ceil method rounds a value to the next closest integer and returns the value. So in this case 4.6 is rounded to the next closest integer, which is just 5.0, and it just returns 5.0. Let me just run this program again and enter a different value. Let's enter something like 2.1. Normally a round method would round this to 2 because 2 is the closest integer, but a math.ceil method rounds it to the next closest integer. After 2 you have 3, so this rounds 2.1 to 3 and it returns 3.0, and so that's exactly what you get. So it's quite simple. And another thing, which is not really an exception but just something that you might get confused with, is what if you enter a value which is an integer but you enter a double representation. So instead of a, let's enter something like 2.0. So let me just first run this program, and for a we'll just enter something like 3.0, 2.0. So let's just enter 2.0. What do you think should happen? I just told you a ceil method should round something to the next closest integer. It should round a decimal value to the next closest integer. So in this case, would it return 3.0? When you run this, you notice it just gives me 2.0. It doesn't give 3.0, because as you can notice, after a decimal point you just have a 0. A 2.0 is the same as a 2. It can't round a 2 to a 3. It can only round to point a certain value to 3. So it's just something that you need to know. If it's something like 4.0 or 6.0 or 8.0, it's always going to return that same value because it cannot round it to the next integer. So now that we've understood that, we look at the math.flow method, which is also really simple by the way. It's just the opposite of the ceil method. So a ceil method rounded a value to the next closest integer. Our flow method does the exact opposite. It rounds a value to the previous closest integer. Basically, normally a ceil method would convert 3.2 to a 4.0, or it would return 4.0 because it's the next closest integer. But if it was my floor method, it would return the previous integer. So before 3.2, the closest integer is 3, so it returns 3.0. It's literally just the opposite of the ceil method. So I just replace ceil over here with floor, and we'll try this program again. We'll see what happens. So let's just run this program and let's enter a value. Let's enter something like 4.7. Intuitively, if I were to ask you to round 4.7, you would say it's 5. But for the floor method, I told you it rounds it to the previous integer. So 4.7, and the integer before that is just 4.0. So if I run this, it just gives me 4.0. It's just the opposite of the ceil method. Now let's see what happens when I enter a value like 2.0. will it round it to 1.0 because that's the previous integer, or as we saw in the ceil method, it would just return 2.0. So when I click on enter, it just gives me 2.0, and this makes perfect sense. There is nothing after this decimal, just a 0. And finally, we're going to look at one of the most important methods. Now, even though it seems simple, you can do so much more with the method. So this is the math.random method, and there are a lot of changes or translations you could do using the math.random method. So a math.random method is pretty simple. It just returns a random double value between 0 and 1. And the syntax is the exact same. It's just math.random and you have your brackets. An important thing that you observe is that you don't have any parameters. In all our previous methods, we took in some value, we modified it and returned it. In this case, we don't have to modify a value. The only function of a random method is just to return a random value. So in this case, the return data type is always a double, because when you're returning a value between 0 and 1, it cannot be an integer, and that kind of makes sense intuitively. So it's going to be a double. And an important thing that you should recall is a double can store a large number of decimal values. To understand this, let me just show you the simple program. What we're going to do is we're just going to add this println statement that just prints math.random. So basically, this should just print some random value, a random decimal value, a random double value between 0 and 1. So when I run this, I don't get something like 0.1, 0.2, 0.3, all of them are valid. But as you can see, I get a really random value. So this isn't useful to us, right? I mean, it would make sense for me to, let's say, return a random value between 1 and 10. That would be a lot more useful than this gibberish over here. So how do I manipulate this method? Now you can just learn the programming part of the math.random method and leave it at that. It's fine. But I really do recommend you learn the intuition behind how you use this method. Now we do know that whenever you use math.random, it returns a random value between 0 and 1. So what I have here is I have a number line, and the blue line over there represents all the possible values that can be returned by my math.random method. It's just returning a value between 0 and 1. And we're going to try something. What we're going to do is we're going to multiply this with a certain value. What if I multiply my math.random method with something like 3? Think about what could happen. Instead of printing math.random, I print math.random times 3. Well then, if you look at your current range of values, I'm just getting a value between 0 and 1. 0 times 3 is just 0, but 1 times 3 is 3. So what happens is, instead of getting the small number of values, you can get a larger number of values between 0 and 3. So you can see how your method changed. Just by multiplying it with a certain value, you can increase the range that it covers. So in this case, if I want it to return a value between 0 and 10, it can do that if I just multiply it by 10. So it's really simple. Now, what if we add something? So let's just get back to original graph over here, or original position. It's just returning a value between 0 and 1. So what if I add something? What if I say something like math.random plus a value? Take your method, math.random, it's just returning a random value between 0 and 1. What if I add a certain value to that output? What would happen? Well, if I add a value, you can kind of think what could happen, right? So math.random plus something like 6. So in this case, I'm getting a value between 0 and 1. 0 plus 6 would be 6. 1 plus 6 would be 7. So what you see is something like this. It's going to be returning a value between 6 and 7. Did the number of possible values increase? No, it didn't. It's still between two integers. But what I did was I translated that. Instead of returning a value between 0 and 1, I can now return a value between 6 and 7. And this kind of makes sense. Previously, I got something like 0.835. When I add 6, I get 6.835. Another important thing you need to remember is that when my math or random method returns a value, it's not including the last value. Basically, when I'm returning a value between 0 and 1, it could return 0 or any other value, just not 1. So now what we'll do is we'll use what we learned. I told you that when you multiply something, you're increasing the range of possible values. So that's exactly what we'll do. So I have a math or random method, and let's say I want to print a random value between 1 and 10. So what I'll do is I'll just multiply this with 10. Now at first glance this shouldn't work because I told you it's returning a value between 0 and 1. 0 times 10 is 0, 1 times 10 is 10. So in this case it's going to return a value from 0 to 10. 10 not included. But let's just first run this and see what happens. So when I run this, I get 8.747. Previously I didn't get this. I always got something like 0.8, 0.9, 0.6. I never got something like 8.7. And I could run this any number of times. Now I got 1.207 and 6.819. You can still see there is one issue. I still have this gibberish over here. I don't want all of that. I just want an integer. I want a value or an integer between 0 and 10. I don't want all of this gibberish. What can I use to remove the gibberish? Well, I have my three methods. I have my math.round method, math.ceil method, and math.floor method. If you use your math.round method, basically 6.8 would be rounded to 7. So I'll get 7. It's still giving me a random value between 0 and 10. If you use your ceil method, 6.8 will be rounded to 7 and it will give me 7.0. You can see that your math.round, math.ceil and math.floor methods can be used to remove all of this decimal gibberish. Now let's try this. Let's try it with the math.round method. Let's try it with a math.round method. So in this case, I'm getting a random double value, and let me just round this. And how do I round it? Well, this should be the input for my round method. So we'll just put my round method over here, and obviously this decimal value or this double value should be the input for my round method. So let's just copy this and let's just add this over here. So now whatever double value is returned over here, again a double value between 0 and 10, it is rounded to the nearest integer. So now when I run this, I'm getting 3. The value could have been something like 2.9, 2.8. It also could have been something like 3.1, 3.2. But it's just giving me an integer. It works really well. Now we could also try it with our math.ceil. And now you see that we get something like 7.0. Now you can argue that the values differ, but that isn't what we care about. The whole point of a math.random method is to get a random value, right? It is still giving us a probability of a value appearing. So this works really well. Now we could also add a math.floor method and it would work in the same way. So when I run this, it gives me 8.0. So the value was something above 8.0 and lesser than 9.0. But something that you notice is your math.ceil and math.floor are usually preferred. Math.round doesn't work that well. And it's pretty simple why. Let's say you get a value like 0.2. It's rounded to 0. Now let's say you get a value like 9.8. It's rounded to 10. But I just told you that 10 isn't included. You shouldn't include 10. But a math.round method does or could round it to 10. So then I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So this could change our output. I want a value between 0 and 10. I want a random value of 10 values. So then something like math.floor or math.ceil would work, because if it was something which is, let's say, below 10, it's probably floored to a lower integer. So my only possibility is from 0 to 9. So that's it. That's all you need to know about the math class. Now I know I took 2 videos to explain all of this, but it is really simple. At the same time, it could get a little tricky. As always, thank you for watching.